All right. So properties of addition. There's a lot of properties, but the only two that we're going to focus on for this chapter is the associative and commutative property. The commutative property states that you can switch the order of add-ins in an addition problem, and the answer will be the same. So if I have 4 plus 5, I can write it down as 5 plus 4 and still get the same answer. All right, the associative property is when you use parentheses to group. When you use parentheses to group add-ins together to make it easier to add using mental math. Now, looking at this one right here, this is a smart grouping, right? Because I know that 7 plus 3 is 10, and I could quickly add 10 plus 4. That's the reasons for using parentheses to group items together, so that you can quickly add them faster. Okay? So, that's what we're going to be focusing on for this chapter. Thank you. This chapter. All right. So the most important thing to know for our test is how to differentiate between the two properties. Okay. So using your whiteboards, I'm going to write down a problem, and you're just going to write an A for associative or a C for commutative. That's it. That's all I want you to do for right now.
Oh, that's easy. Simple, simple. So easy. I forgot.
All right. So A or C?
Got it. Not ready.
Okay, show me in 3, 2, 1. All right. Associative has what?
Parentheses.
Okay, associatives have what?
Parentheses.
Okay, commutative means I can change numbers around and the answer is still the same. So this is C.
Yeah. So this is gonna be like the easiest thing in the world. Wait until we do the math.
Associative or commutative?
Don't do. What is that?
Okay, show me in 3, 2, 1. Good. Associative. A. Associative or commutative? Put him down, please. Associative or commutative?
Stuck it out.
Show me in 3, 2, 1. Good. Should be C. Commutative. Good.
What is oh wow! C-A-C-A. Oh geez.
Show me in 3. Oh, sorry. Associative or commutative?
Oh, that's easy. There. Oh.
Okay, show me in 3, 2, 1. Good. It is commutative. Last one. This one's going to be tricky, so look at it very carefully.
Okay. Tell which one's commutative. Make sure to almost put parentheses. Oh, parentheses. Oh my gosh, I'm so tired. Boom. Oh my gosh.
Look at it carefully. What property is it? Nope.
If you could change numbers around.
I warned you, it's a trick question. Okay, show me in 3, 2, 1.
Mine was A, by the way, Miss Friendly. That was A. I'm still landing on the right side.
High five.
What
You
is
get a
it?
piece of candy out of the middle cabinet. It has both properties.
Oh.
I switched the numbers around and I switched the grouping.
I knew it was. I knew it. I was right.
Associative and commutative property.
So you can do that? You just swap them out?
All right, this first one, if you look at it, or what do you think it is? Maricela. You believe it's associative. Do you guys agree with that?
No.
Well, thumbs up, thumbs down. Abba, say why not? Okay, so commutative tells me that if I switch things around, right?
Yeah.
Okay, so 6, 12, 6, 12, 3, 12. Is that the same order as 6, 12, 6, 12, 3, 12?
Yes. No.
Wait,
No.
yeah.
Yes.
I have 6, 6, 3, 6, 6, 3. So that is associative.
Yes.
That's why I said take a look at the order of the numbers. Okay, how about this one right here? Levi. Commutative. Why?
Commutative because it's 352 and then the other one is 325.
All right, so the order changed, right? We have 3, 5, 2, 3, 2, 5. Good, commutative. Yes, Elise, you have a question? Okay. All right, this one. Next one. Elise?
It's commutative.
Why?
Because it goes 4, 3, 2, 3, 4, 2.
Good. Commutative. And last but not least, Isabel, what do you think? Why do you believe that?
Because it's like
What did Miss Fernley said to remember? What are we looking at when we looked at this stuff? The order of the order of the numbers. Say it. Okay, so the order of the numbers for this one is 1, and then a single fraction and 3. 1, single fraction, 3. Does the order change?
Yes. No.
1, single fraction, 3. 1, single fraction, 3. Does the order change?
No.
Okay. So if the order doesn't change, then it's a associative. Okay. All right. Any questions about that?
No.
Okay. Always look at the order when you're trying to figure out associative and commutative. Look at the order of the numbers. All right. Let's take a look at 710. Okay, let's take a look at the first word problem. Okay, a gift shop sells walnuts in 3/4 pound bags. Anne will buy some bags of walnuts and repackage them into 1 pound bags. What is the least number of 3/4 pound bags Anne could buy if she wants to fill each 1 pound bag without leftovers? Okay, so what do we need to find? Levi.
If it's commutative or associative?
No, we're past that. That was 7.9. Look at the problem. What is it asking us to find out? Ivan. No? That's one thing you guys got to really make sure that you understand when you're reading a word problem. What are you supposed to find out? Maddox.
How much you could buy without leftovers?
Okay, what is the least number of 3/4 pound bags Anne could buy if she wants to fill each 1 pound bag without leftovers? Okay, so we know that she has 3/4 pound bags, but we want to fill a 1 pound bag. So if I have 3/4, I have this, and this. Okay, can that fill is that the same thing as a pound? 3/4 is the same thing as a pound, no? Okay, what if I added another bag? What if she bought another bag of 3/4?
Yes.
Now, is that the answer?
No.
Why?
She would have leftovers.
Because she'd have leftovers, right? So if I put these two together, I'm going to color in 1, 2, 3 from this one. 1, 2, 3. And then I only need 1 from this one to make a whole pound bag. But how many do I have left over? 2. Okay, now what do I do then?
You have to do this one. Actually, you have 1 because you colored in 3.
Right, I colored in 3 and then I took 1 from the other pound bag. So how many do I have left? 2. Okay, now what? Maricela, Alexis, unless you know how to solve this, I suggest you turn around and take a look at me.
I think I know.
Okay, so I have 2 left over, right? So let's bring it down here. So I have 2/4 left over. So I have 1 pound bag, but I have leftover, so I got to keep going. So I got to keep doing what?
Keep adding up.
Adding 3,
say
4.
3 until you get up to where you don't have any leftovers.
Good. I'm just going to keep adding until I have no leftovers. So I'm going to add
I was thinking of that, but I'm sure.
another third. And what does that give me?
5/4. No, you can't have 5/4.
Okay, so if I take the 2 that I had left over from the previous one, right? And I'm going to add, how much space do I have?
2 spaces.
So I can only take 2 of these pieces, right?
Yeah. You still have leftovers.
But do I still have leftovers?
Yes.
Okay, so what do I got to do now?
Add again.
Okay, so how many have I bought already? I've bought 1, 2, 3, but I got to buy another one.
4.
So I'm going to take my leftovers from that one, which was how many pieces? 1/4. So that's 1/4. And then I have to buy another 3/4. And what does that give me?
4/4. 1 pound. Another pound I need.
Okay, so I can take my 1 from there, and I take 1, 2, 3. Do I have any leftovers now?
No.
Okay, so how many did I buy?
You forgot the 1 on the middle one.
4.
That's your answer, 4?
Multi-step problem. So my answer then would be, I would need 4 3/4 pound bags. And how many 3-pound bags would I be able to make with it?
4. 3.
How many pound bags can I make with it?
4.
No, count the ones.
1, 2, 3. 3 pounds.
Okay, kind of hard, right?
It's too complicated.
Sorry, that's life. Life is complicated.
Wait, how many did we do? 1, 2.
Okay, so I bought 1, 2, 3, 4 3-pound bags, and I was able to make 1, 2, 3 whole pound bags.
Wait, we said about 4. And we made 2.
Okay, so if I take a look at that, what did I do as far as an addition problem? I did what's 3 plus 3 plus 3? 9 plus 3 plus 3 plus 3. Okay, 3 times 4 is 12. Now if I divide that and make it into a whole number.
That makes life easier. You have 6 left.
Okay, so you can draw pictures, or you can just add until you get a number. Until you get something that you can make a whole number, okay? So if I just did this, 3/4 plus 3/4 gives me 6/4, right?
Yeah.
Can that make a whole number?
No.
No, so I gotta keep adding. That makes it a whole number. Can 9 be divided by 4 evenly?
No.
No? Okay, so I gotta keep adding.
Yeah.
Now, does that make a whole number evenly?
Yeah.
Okay. So that's the first problem. Second problem.
Problems are easy. Whoa.
Okay, at the end of dinner, a restaurant had several dishes of quiche, each with 2 6-size pieces. So how much is my circle going to be?
6.
I can't ever do 6 right. Sorry. No, because it doesn't go across. With 2 6-size pieces of quiche, the chef was able to combine these pieces to make 2 whole quiches. So I need 2 holes over here. With no leftovers. How many dishes did the chef combine? So each of these is going to have just 2 pieces colored in. And how many do I need to be able to get to here?
2 holes. 6.
How many will I need? This is 1 hole, right? Or 6 over 6. Okay, so if this is 2 6, and I need to get to 6 6, right? Okay, so I'm just going to add. 2 plus 2 is? 2 6 plus 2 6 is?
4 6.
Okay, is that 6 6? No, so I need to add again. 4 plus 2 is?
6.
Is that 6 6?
Yes.
Okay, so how many pieces did he have to do to make 1 hole?
3.
3. Good, let's make another hole. Because it says here that he made 2 whole quiches. So if I made a hole here and I had 3 of them, what do you think I'm going to have to do down here? Same thing. 2 6 plus 2 6 equals 4 6. Nope, that's not enough. So how many here? And 3 plus 3 is?
6.
Okay, so how many small size quiches or half 2 6-size quiches does he need to do to make 2 holes? 6. Good. Okay. I know it's difficult, Isabel. I need your focus. Okay. So it's very important that you understand what you're reading. Now, go ahead and tear out 710. We're going to do that as a class. These problems in. All right, so number 2 says that Val walks 2 3/5 miles each day. Bill runs 10 miles once every 4 days. In 4 days, who covers the greater distance? Where's one of it? There's one. All right, so we know Bill.
We do? Yeah.
We know Bill goes how many in 4 days? How many miles?
This goes to 10.
Bill goes how many miles?
10.
10. Okay, so do we have to figure anything out for Bill? No, but we do need to figure out for Val. And Val states that 2 3/5 miles each day. How do I figure out who does more? We're not multiplying and dividing yet. That's the next chapter.
Miss Burnley, you.
Minus is the answer.
Damien. Okay, I'm going to add this 4 times. Okay, because it's 4 days. So 2 3/5 plus 2 3/5 is what?
Equals 6 and 4/5.
Solve it on your whiteboard.
4 6.
No.
Wait.
Solve it on your whiteboards. What's 2 3/5 plus 2 3/5?
2 3/5 plus 2 3/5.
All right. So 2 3/5 and 2 3/5. All right. So if I add these together, I got 3 plus 3 is 6. Can I leave it as 6/5? No. So what do I do?
You gotta add a whole. So you subtract 5 5 and you put it up and then.
Good. So I put that up there. Which leaves me with what fraction?
5
1/5. 2 plus 2 is?
4.
Plus 1? So my answer is 5 1/5. Am I done?
Yes.
So the answer is about. So the answer is Belle ran 5 1/5 miles.
Yep.
In 4 days. No, why, Isabel? Maddox?
2 and 3/5 and 2 and 3/5 was only 2 days.
That's only 2 days. And I need how many days?
4.
4. So what can I do then?
Add again.
Jimmy?
I think I got the answer. Multiply them by 2.
No, we're not multiplying fractions yet. Bailey?
Add.
Add what? Do I need to do this all over again? Okay, what can I do then?
Add it again?
I can add it all over again, yeah.
Add it.
So do I can keep adding. Erase this. So I'm going to add 2 3/5. 1 plus 3 is?
4.
4. 5 plus 2 is?
7.
Can I have that?
Yes.
Lucas, put that down, please. Is this an okay mixed number?
It's a mixed number, but it can't be.
Why?
Because that'll only be 3 days.
Right, I didn't say if this the answer. Okay, I've got 3 days now. But 7 4/5 is an okay fraction, right? I don't need to regroup?
No.
No, because the numerator is smaller. Good. So I'm going to add how many more? Do I need to add again, Lucas?
Yes, you add again. You need to add 2 and 3 and 1.
Okay, 4 plus 3 is?
7.
Can I leave that?
No.
No, what am I going to do?
Group it.
Okay. Who wants to show me how to regroup it, or tell me how to regroup it at least? Natalia.
You subtract it by a whole.
Okay, what is a whole?
5/5.
Okay, and that goes.
On the total.
Okay. And what do I have left?
You have 2/5.
Okay, good. I have 2/5. Now what? Elise?
7 plus 2 plus 1.
Okay, 7 plus 2 is?
9.
Plus 1?
10.
So what is my answer?
10 and 2/5.
10 and 2/5. Yes.
1 plus 2 plus 5 and 1/5 plus 5 and 1/5.
Okay, Maddox says. Okay, does everybody kind of understand how I got here?
Yeah.
Jimmy, you have a question? Yes, Maddox just said that, and I'm about to talk about it. Okay, no questions about how I got here like this, by continuing to add and add and add. Okay, Maddox tells me that since I already did the addition up here, I already did 2 days, and I know that 2 days equals 5 and a half. So what is 2 more days going to equal?
5 and a half again.
5 and a half again. So can't I add those?
5 and 1/5. 5 and
1/5. Thank you.
But it's not 5 and a half. I meant.
Okay, 5 and 1/5. So can't I just add those 2 days together, or those 2 numbers together?
Yeah.
And get the same thing?
Yeah.
Okay, what's 1 plus 1?
2.
5 plus 5?
10.
Okay, but if you don't get that, then just do repeated addition.
Okay, that's what
All right, let's take a look at number 3.
So the answer is 10. The answer is 10. Yeah. 10 to 5.
Okay, number 3. I'm feeling like everybody's talking when they shouldn't be. Number 3 tells us Chad buys peanuts in 2-pound bags. He repackages them into bags that hold 5-6 pounds of peanuts. How many 2-pound bags of peanuts should Chad buy so that he can fill the 5-6 pound bags without having any peanuts left over? Okay, how can I solve this? This is kind of like the ones that we did before. Do you guys want to do these by yourself?
No.
Okay, then I need some participation. What do I need to do? Elise?
You can draw a model.
Okay.
Can we do that?
What do you want that model to look like?
How we did like the circles.
Okay. So how many pieces are in a circle?
6.
Okay, 6 pieces. Okay, and how many should be colored in that model? 5. Okay, so we're going to add 5, 6 until we have no left over. Okay, so if I take 1, 2, 3, 4, 5. Oh, let me draw mine. How many pieces would I need from this one? 1. Okay. Which gives me how many pieces left over?
1.
How many left over?
1.
No, please take a look, Haley.
2.
Instead of yelling out numbers, because you're not even looking.
5.
Show me on the fingers. How many pieces do I have left over? Okay. I see 1, 2, 3, 4 pieces left over. Are you guys seeing something different than I am? Abishai, where'd you get your 2? Okay, but that's not what we do, right? There's 5, 6 pounds. So there's 4 pieces left. This is 4, 6. Plus another 5, 6. Okay, so if I take the 4 pieces from this first one and add how many from this one? 2. Okay, how many pieces do I have left over?
3.
I have 3 pieces. Okay, we could just keep going on and on and on about this, but I don't really want to because that takes a long time. So I'm just going to add until I get whole numbers. On your whiteboards, I want you to add 5, 6. 5, 6 plus 5, 6.
So we get to a hole?
Till you get to a hole. Eyes on me. Hey, if it helps you, do the multiples. What are the multiples of 6?
6, 7, 18, 24, 32, 36.
Okay, so we have to add the top numbers till we get to one of these numbers. What's 5 plus 5?
10.
Is that one of these numbers?
No.
Plus 5.
15.
Is 15 one of those numbers?
No.
Okay, plus 5.
20.
Is 20 one of those numbers?
No.
Plus 5.
25.
Is 25 one of those numbers?
No. 30.
Is 30 one of those numbers?
Yes. Stop yelling at my ears.
So how many times did I add? 1, 2, 3, 4, 5, 6. Okay, those of you that had 5, if you just did the division here, 30 divided by 6, that's 5. But that's not what it asked, right? It asked how many he bought. Okay. Last one.
So fast.
Okay, yes, the answer was he needed to buy 5 6-pound bags. All right. It says a carpenter has several boards of equal length. He cuts 3/5 of each board. After cutting the boards, the carpenter notices that he has enough pieces left over to make up the same length as 4 of the original boards. How many boards did the carpenter start with? Oh, my Lanta. Okay.
This one hard?
This one's hard even for Miss Friendly. All right. Yes, we have to do it.
So if we had homework, we would have probably never found this out.
No, Miss Friendly can figure it out. All right. So he cuts 3/5 of the board of each board. After cutting the boards, carpenter notices that he has enough pieces left over to make up the same length as 4 of the original boards. How many boards did the carpenter start with? All right, so if we have 4 whole boards, and we're cutting them into fifths, what would be, how many fifth-size pieces would be in 4? How many fifth-size pieces would be in 4? Jimmy. Huh? Okay, so if I have this board, right? I'm going to draw 4 boards. And I'm going to cut them into how many pieces?
4.
Nope. How many pieces am I going to cut them into?
5.
Okay, so how many pieces am I going to cut them into?
5.
Thank you. Well, I'll move out of your way in a second. Okay, 5 pieces, right? So how many total pieces do I have? How many total fist-sized pieces do I have? Ivan, count again. I have 5 here. I have 5 here. I have 5 here. And I have 5 here. Esme, 20 pieces. Good. Okay, so 4 boards will equal 20 fist-sized pieces. So what do you think I'm going to do? What do you think I'm going to do to solve this? Jenna, add until I get to
20 fists.
20 fists. Do it on your whiteboard. And hopefully Miss Fernley's right.
Wait, were you gonna add 20 fists?
No, that's not right either. All right, so here's the key word. Okay, this is on your quiz, so I suggest you guys pay attention.
Okay.
All right. So if I cut these boards into 3 fists, so I'm going to cut them, right? How many pieces do I have left over? Because it says left over here. How many pieces of each board do I have left over? Malia?
2.
2 what?
2 fists.
Okay, so what number am I going to add until I get to
2 fists. 2
fists?
fists.
So add 2 fists, because that's what was left over until you get to 20 fists. Okay, so basically if you skip count 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so you're just skip counting. 8 fists. 1, 2, 3, 4. What is not right?
This is 2 plus
2 plus 2 is 4.
No, 2 fists plus 2 fists plus 4 fists.
Oh, it's supposed to be an equal sign right there. Okay, and I keep doing this until I get to 20. Your answer should be 10.
You put plus 2, 8.
All right.